Okay, so today we are going to discuss how to find chiral center. You know, most of the students are having many difficulties in determining the chiral center. So first of all, number one thing is that chiral center means when carbon, the central carbon is having four different groups attached. This is A, this is B, this is C, this is D. It means this carbon is a chiral carbon. Okay. So number next thing is that if this is a chiral center, so of course it would be showing optical isomerism. Right now, I'm not discussing optical isomerism. The goal is to determine in an easier manner how many chiral centers are there in a given molecule or a compound. So number two, the double bonded carbon can never have a chiral center. Remember, double bonded carbon, whether the carbon is in the ring, whether is in the long chain, it would never have a chiral center. Okay. And most of the time you will see skeletal formula in which you have to find out the chiral center. So let me tell you one thing, whenever you can see the benzene ring like that. So few points that you must remember keeping in your mind before going to determine the chiral center. Number one thing is that all carbons are double bonded. Okay. So I don't have any chiral center. Remember, because I told you the double bonded carbon is not having a chiral center. What if I have cyclohexane in which there is no double bond? Still, I don't have any chiral center. If you are asking why, we are not having any chiral center because this is a skeletal formula in which we have the two hydrogen atoms with each and every carbon. Let's say these are having two hydrogen atoms because the valency of carbon is 4. So it has to fulfill the valency. So every corner is representing the carbon atom, and each carbon is going to have two hydrogen atoms. So again, you can say same and same. It can never be a chiral center. No, 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 and no. Because to be a chiral center, it must have different groups attached with the chiral carbon. That's the criteria. That's the criteria, right? Okay. And then let's talk about some questions. Let's say I have to tell the chiral center in this molecule, right? Just look at this carefully. What I'm going to do, number one, let's suppose if I talk about this carbon atom, okay? So this is CH3, okay? This is CH3. This is understood. This is understood. This is CH3 because this is the skeletal formula, okay? Right now, I'm not supposed to tell you how to like how to write down the skeletal formula. Hopefully, you know it. You know it very well. Okay. If you are not having a proper idea regarding the skeletal formula, so please, you are not supposed to practice the chiral center until or unless you must know how to draw the skeletal formula in a proper manner. And by the way, every corner represents the carbon atom. So this is corner, 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 corner. All are carbon atoms. Then we have to see is there any same group or not. So this carbon is having this CH3 and this is CH2CH3. Of course, this is a skeletal formula. There is one hydrogen as well. And this is CH2CH2CH3. So if you can see around this carbon atom, all are different. And this is different, right? Different. So four different groups attached with the central carbon atom. To make it easier, only for this one, I'm going to write down in this manner. This is carbon. It's going to have CH3. This is C2H5. This is hydrogen atom. And this is C3H6. For, for make it simple, this is C2H5. And this is, of course, hydrogen, CH3, C3H6, right? Hopefully you know it how I'm going to determine the chiral center in the given compound. So whenever you are having any difficulty in determining the chiral center, you have to use structural formula, okay, or displayed formula as per your feasibility. And then you have to see how many chiral centers I have. Let's say if I have this one. So, so if I talk about this carbon atom, OH is different. This is CH3, that is different. The whole ring is different. And this is H. Of course, this is skeletal formula. We don't show hydrogen, but there is hydrogen. So this is different. So this is chiral. So in this compound, we have only one chiral center. Okay. And this is double bond. It would not be a chiral center. Always remember, whenever you can see this line, okay? Only one curve. Just make it simple, okay? So this is understood. The, it has two hydrogen atoms, isn't it? It can never be a chiral center. You can see the design. This one, no chiral, no chiral, no chiral, no chiral, right? Isn't it? Because there are two hydrogen atoms. So whenever you can see this line, so this is not a chiral center. We must have like this pattern, like this one, like a junction, like a junction, more than two ways. So then I would check it, then I would see, then I would like consider, am I supposed to check the chiral center or not? If I'm thinking, I'm checking yes or no, I'm wasting my time. You are wasting your time. Why you are thinking about this card? It can never be a chiral center. Remember, this is a chiral center. Sir, why this is a chiral? CH3, this is hydrogen, this is different, this is different. So you have to be broader mind, you have to have a broader mind, if you are going to like determine the chiral center. Don't be like, sir, this is carbon, so how can it be a chiral center? No, you have to consider the whole and soul neighbor. Like this is the neighbor, this is the neighbor, this is CH3, this is hydrogen. Then you will be able to find out the chiral center, right? Okay. And I would not look at this. I told you this is double bonded. I would not look at this. 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 Isn't it? I would not look at this. I would not look at this. I would not look at this. Three hydrogen atoms. I would not look at this. And I would not look at this. Oh my God. And then what are the remaining ones? So this is chiral. This is chiral. This is chiral. Sir, why this is chiral? Let me tell you. Different, 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 and there is one more hydrogen, and that's going to be different, isn't it? This is the chiral center. So just keeping in your mind, how can we determine the chiral center? I'm going to upload this file in the description, in the comment section. Just click on the link, you will get this file. Just complete it and then ask if you are having any difficulty in finding out the chiral center. Okay, thank you.